Hi everyone, welcome to Advanced Functions. In this lesson, we're going to explore learning about absolute value. Our learning goal today is to understand absolute value, be able to solve absolute value equation, represent an interval notation by using inequalities, and be able to draw a transform graph from a parent function. First, we need to understand what absolute value is. So absolute value of a real number, x, is a distance between that number and 0. So absolute value is represented using a straight line on both ends of a real number. So for absolute value, you always have to divide it into two sections. The one that is positive, so we say x, it's a positive x if we say x is greater than or equal to 0. And it's going to be negative x if x is less than 0. Now keep in mind that you will notice that the equal sign is only on one of them. In this case, only to the positive. You cannot have an equal sign to both cases, only one or the other. So here are the absolute value properties that you have to memorize and understand. First, any absolute value of a real number is going to turn it into positive. So that is the special characteristic. So for example, if I were to have an absolute value of negative 3, it's going to equal to positive 3. Again, if I have an absolute value of 3, it's going to turn it into positive 3. Why? Because it's, like I said, it's the distance from that number to 0. Absolute value of 0 is just 0, and you can divide up into separate multiplication for absolute value and for division. And keep in mind, if I were to have a separate absolute value of addition, it's going to be definitely greater or equal to than when you combine it within the same absolute value. So let's try some questions. Question number 1, simplify. I'm going to simplify the absolute value within. So for numerator, negative 2x is going to turn it into positive 2x. And then same thing, it's going to turn it into positive x. And then you will notice that x and x cancels out. So therefore, simplified answer would be 2. Next, let's simplify. The absolute of x is just x minus, what is the absolute of negative x? It's going to turn it into positive x. So I'm going to write positive x. And then we have x minus x, which is 0. Now we're going to solve for x in inequality. When we're solving for x, you have to divide it into two sections. Like I said, one that is positive and the one that is negative. Okay, so in this case, we're setting 2x minus 1 to be greater than 0 or equal to. And for this side, we're setting 2x minus 1 less than 0. So if we're setting it greater than 0, it's going to be positive. So 2x minus 1 positive equals 3. So therefore, 2x is equal to 4, x is equal to 2. For the negative side, you're going to put negative around the whole absolute sign. So negative, and then instead of writing absolute, 2x minus 1 is equal to 3. Okay, and then you're going to do the distributive property. Negative 2x plus 1 is equal to 3. So negative 2x is equal to 2, x is equal to negative 1. So we have two possibilities for x when it's an absolute value. Now let's represent interval notation using inequalities. Now, just a reminder, inequality is using a comparison operators. So comparison operators include less, less or equal to, greater, greater or equal to, or equal sign, or does not equal to. Okay. Now there are three notations that you can represent the domain or interval notation. So first one is inequality notation. So inequality using greater than or equal to. So in this setting, x is greater than a, but less than or equal to b. Another way to represent interval notation with the same expression, so you will notice that there is an error here. So there is a square bracket and a round bracket. So the square bracket, it means it's including or equal to. And the round bracket, parenthesis, is excluding that number. Okay. The correction that I would like to make, as you can see, is x is greater than 2, but it's not including here. So therefore, it should be a round bracket here. And then x is less than or equal to. Because it's equal to, this one, it should be a square bracket because it's including b. So please make a correction here. Now the third notation is a set notation. Set notation is very similar to inequality. The only difference is that it's including a domain where x is a set of real number. Okay. Now we can represent all of this notation using a linear line graph. So as you can see, an open circle represents that it's not including, so it's excluding the round. And for B, it's including B, so it's a closed circle. Okay. So let's take a look at another example. For inequality notation, what we have over here is x is greater than or equal to a. So therefore, for interval notation, x belonging to, and you'll notice that because it's an equal sign here, we have to represent using a square bracket. And then x is going to keep going up forever, increasing. So infinity sign. And you never ever put a including for infinity. Okay, so this does not happen. It's always excluding, a round parenthesis bracket. Okay, because you never know when it's going to finish. And then you can represent the set notation with x belonging to a real number such that the same inequality notation. And you can represent using a number linear graph this way. So including a and the graph, the value is going to keep increasing till infinity. Let's do an example. Rewrite using the absolute value notation. Now, in order to write it in an absolute value notation, the numbers have to be exactly the same number, but opposite sign. So the value has to be same. So in this example, the value is exactly the same. We have 2 and 2, except that just the signs are different. Then we can represent using absolute value notation. So if x is in between negative 2 and 2, we say x absolute value is less than or equal to 2. So that is the absolute value notation using inequality. If I wanted to represent it, if I wanted to represent using inequality, then x is less than or equal to 2, but greater than or equal to -2. Okay, so those two will be the same expression. The next example is, so this is A. Notice if you can write absolute value notation. So let's check. So right now we have a starting point at 0 and 2. Are the numbers same? No, they're not. 1 is 0 and 1 is 2. So unfortunately, for this one, you cannot represent using absolute value notation. But instead, you can write it using inequality notation. So x is less than, but it's not equal to because it's an open circle, 0, and or x is greater than 2. Now this is a symbol that you will write down. So it's like a union for inequality. So rather than writing or and, you write a union of for inequality symbol. Now lastly, we're going to take a look at the transformations for an absolute value. But to do that, you need to understand the final transformation variables. Okay, so this transformation function is given from let's say, for example, the function could be parabola. So this can apply to any type of function. So that's why we represent using f here. Now there are 4 variables that I want you to take a look at: a, b, c, and d. So number 1 and 2, 1 and 2 represents transformations. And 3 and 4 represents a translation. So translation is up and down, left or right by adding or subtracting. Transformation, you are multiplying or dividing by that factor. So let's take a look at A. First, you look at the sign of A. If the sign of A is negative, we say it's a reflection in the x-axis. If A is greater than 1, then we say it's a vertical stretch by factor of A. If A is less than 1, it's a vertical compression by factor of A. So a vertical stretch will be looking like this, very narrow, and vertical compression, you're pushing it down, so it's going to be very wide. And reflection in the x-axis, it will be going downward, assuming that we are working with a parabola. Now let's take a look at B. If B is negative, then we say there's a reflection in the y-axis. So for a parabola, it's going to look exactly the same because they are symmetrical. Now anything that is inside the function, so specifically B and C, we have to think opposite. So for B, we're going to flip it. And for C, we're going to do the opposite sign. So for example, if B is greater than 1, we say it's a horizontal compression. Why? Because we're going to flip it by B. So it's like 1 over B. But if B is less than 1, we say it's a horizontal stretch by factor of 1 over B. Okay, so that's the key information. It's reciprocal of B. And for C, if C is greater than 0, then we say it's moving to the right after you take it out of the bracket. So it's always opposite sign. And if it's less than 0, we move to the left. And lastly, for D value, for D, it's not inside the function. So you read it as it is. So if D is greater than 0, it's shifting up. If D is less than 0, it's shifting down. Let's do some practice using transformation. So we are always transforming from absolute function parent. So the parent function looks like this. It's symmetrical V shape. So as you can see, we have a C value, and it's inside the function, inside the absolute. So what we're going to do, we're going to flip it, do the opposite sign. So if I were to flip it, this C is going to be positive 3. So therefore, if it's positive 3, we're going to move to the right by 3. So 1, 2, 3. At 3, the graph is going to look like this. Exactly the same shape as absolute value of x. It's shifted to the right 3. Next, you'll notice that it starts with number 3 minus x. We don't like that. So what we want to rearrange it so that x is starting first. So y is equal to negative 2, absolute, negative x, plus 3. Now, when it starts with negative inside the bracket, we are going to factor the negative. So y is equal to negative 2, negative, factor, x, minus 3, and close the bracket. So you must factor whatever's in front of x when you have an expression inside the bracket. This negative means it's a reflection through the x-axis. We also have reflect through the y-axis. This 2 is greater than, so a is greater than 1. So what does that mean? We only look at the value, not the sign, okay, for a. So we say it's a vertical stretch by factor of 2. And then this negative 3, again, it's inside the function. You got to flip it, do the opposite sign. So this c is going to turn it into positive 3, meaning we're going to move horizontally 3 steps, which is right 3. So when you're doing transformation, make sure you do the reflection first, transformations, and then lastly, translations. So let's try it. So we are given the original function. From the original, we're going to reflect through the x-axis. We are going to reflect through the x-axis and reflect through the y-axis, which is exactly the same because it's symmetrical. And then it's vertical stretched by 2. So it's going to be very narrow by 2 times, be a little bit narrow. And lastly, we're going to move to the 3 steps to the right. Exactly the same shape. So this is going to be my transform function for this graph.